Awesome. Okay, 6-1. Area between curves. Let's imagine that you have two curves. So these two curves could be anywhere on your X and Y axis. So let's say this is one, and this is another one. The graphs are going forever. Let's say you want to find the area from the point A to point B between these two curves. Let's name one of them to be f of x and the other one to be g of x. Okay. So now you want to find the area between these two curves. So that means from A to B, you want to find this area. Tell me, if I was taking small triangles, small rectangles. Let's just look at this, a small rectangle. Since I'm cutting it along x-axis, the thickness here, you tell me, the thickness here, do you think is dx or dy? Which one? The thickness of this, or the width of this rectangle. If I want to name it to be dx or dy, which one it is? Which one is your guess? It is dx. Because it's going to be small difference along x-axis. So whatever is from here to here is difference of x's, so it's dx. What is the width here? I want to try it out with a number first, and then after you're convinced, tell me what would be the general. Let's say this is 5, and let's say this is -4. Tell me what would be the length from here to here? The length, the measurement of the length. Awesome. More ideas, great. So all of you tell me, what would be that measure? What would be that length? Yeah, exactly. The top, which was 5, minus the bottom, which was -4, whatever that was, -4, and this was 5. I would just arbitrarily name that. So you would say 5 minus -4, and that's +9. If you were thinking it the other way, this was 5, this was 4, together it was 9. So if I want to generally name it, do you agree that I can say this length is the top, the y value of the top minus the y value of the bottom? So y value of top is f of x minus the y value of the bottom one is g of x. So the measure of this length is the equivalent of f of x minus g of x. Again, because it's corresponding to the y value of the top minus the y value of the bottom. Okay. Now, if I want to find the area of one of these rectangles, do you agree that it's f of x minus g of x, the difference, whatever it is, times the width? So if you think of length times width, so I would say length of this rectangle is f of x minus g of x. The width of this rectangle is d of x. So the area of this rectangle is length times width. So that's this times this. But that's for a very small portion of the graph. So I'm adding all of them up from my start point to my endpoint means I have many of these rectangles. So I'm taking the integral from A to B, saying my points start from A, adding all those little rectangles all the way to B. So this is the area between these two curves. I could have also write it as of two separate things, f of x dx from A to B minus integral of g of x dx A to B. These two are exactly the same thing. I was just separating the integral over dx. So do you see subtractions? Either of the two. I use this one more often, and then sometimes I need to separate it, I separate it. Any questions so far? Okay, let's just confirm our equation with a more sensible example, and then we're going to expand the examples to be with different types of graphs. So example 1 for today. Find the area of the region bounded by y equal to 1, y equal to 8, x equal to 0, and x equal to 1. So they need to tell me the boundaries, and here is the graph. So you want to find the area bounded by y equal to 1. So let's say this is y equal to 1. This is y equal to 8. So let me just write them, y equal to 1. Every time with math, you gotta be patient. You need to graph it, you need to understand it. So x equal to 0 is y-axis. And x equal to 1, let's say here. So the area that is bounded, it's something like this. Without a use of integral, tell me what would be the area of this shape? What would be the area of the pink one? Great. So you would say it's the length, which is in this case, the measure of that is 1, times width, the measure of that is 7. 1 times 7 is 7. So that's the area of rectangle. But let's just see if that works with an idea of our integral and difference of two functions. Let me take a small chunk. Every time I like you to graph that a small chunk with any type of graph that you're setting up the integral and you're evaluating the area in between two curves. So do you agree that the difference is dx? So I'm setting up my integral. I know the difference is dx. Then I would say the top function, which is 8, minus the bottom function, which is 1. So the top function, y of the top one minus y of the bottom one. In this case, the f of x is just 8, and the f of x or g of x is just 1. And your function, so since this is dx, please pay attention to this. Since this is dx, my beginning and ending points would be along x-axis. So it goes from 0 all the way to 1. So that's my integral setup. Top function minus bottom function from 0 to 1. Okay, 0 to 1. 8 minus 1 is 7, so 7 dx. I want you to evaluate this integral. What is integral of 7? Just 7x. Going from 0 to 1. Substituting the upper, 7 times 1. Minus substituting the bottom one, 0. So the answer is 7. So just this example was sort of confirming our formula. So in this case, it was easy from the beginning to tell what is the area between these two curves because it was a rectangle, but we wanted to see if the setup works. Now let's do another example. Any questions so far? Okay. So for everything, remember to have at least a rough graph of how things look like before finding. So now let's go before finding the area between two. So example 2, find the area of the region enclosed by y equal to x squared, and then y and y equal to 2x minus x squared. Okay, so I want to give you a moment. I want you to give me a rough graph of the two functions. Just try to graph it. Try to see if you can come up with the intersections. You may pick points. You may find, so these are both parabolas. So you may find their vertex, so on, whatever method you have in mind. Just graph these two functions quickly to yourself. Okay, let's.
This meeting is being recorded.
I have a quick question.
X squared is an upward graph. You agree? Because the coefficient is 1. 2x, the leading coefficient is positive. So 2x minus x squared is downward because a, or the leading coefficient, is negative. So you're expecting that to be downward somewhere, so something like this. And there would be some shift involved. So now you want to find where the two graphs are intersecting. You know that one is upward, one is downward. So in order to know the intersection of two graphs, you're going to put the two functions equal to each other, because you want to know where their x's are equal to each other. Right? So now bring everything to one side because it's a quadratic, and then solve for x. So I'm going to add x squared. I'm going to subtract 2x. So that's 2x squared minus 2x equal to 0. So now, tell me, how do I solve here? So if you mess up, someone asked if we mess up writing the top minus bottom incorrectly. So I assume that your answer would come out as negative. So for the area instead of positive, so that's probably where you should know. Okay, so you factor 2x and you have x minus 1 equal to 0. So 2x is 0 or x minus 1 is 0. So from here, x is 0. For here, x is 1. So at x equal at 0 and at 1, the two functions are intersecting each other. At 0, it's 0, 0. At 1, they are both 1, 1, because if I plug in 1 into x squared is 1. If I plug in 1 into 2 times 1 minus 1 squared is 1. So one graph upward, the upward one is x squared. And one graph downward, so that's y equal to 2x minus x squared. Is that clear so far? So you want to find the area in between these two curves. So the area between two curves must be always positive. So here we go. Set up the integral. Let's make the cuts. If the cuts were made horizontally, so just we're going to do some examples with that. If the cuts were made horizontally, then the difference would have been dy. Sometimes horizontally is easier, sometimes vertically is easier. So let's just do a dx first, and then for the same question, we can set up dy so you see our final answers are the same. So let's do this. If I cut it this way, it would be dx's. So let's do that. So the difference is dx. So I'm going to put dx. Now you tell me. What do I put? 2x minus x squared minus the bottom one, which is x squared. It's dx, so I go with minimum and maximum of x, which is in this case 0 to 1. So I want to give you a minute, look at the setup, see if that makes sense, and then also evaluate the integral. So 2x minus 2x squared dx. So evaluate the integral and tell me what you get. Do you all have that? Anyone needs more time on it? Okay, let's just do it with now setup of dy. Let's say if I was cutting it instead of vertically, I was cutting the rectangles horizontally. For these type of questions, you need to be mindful which one is easier. In this case, it really doesn't matter. But there are some that horizontal cut versus vertical cut makes a difference. So in this case, I'm cutting the rectangles. Basically, I'm adding all the rectangles this way. So let's just imagine one rectangle. Then what is the width here? Dx or dy? The cut. Dy. Now I need to find the measure of, you know what, in this case, it's gonna be a little bit difficult to find it, but I'm gonna tell you why, but to do it horizontally, but at least let's discuss it here. So then now you wanna find the difference to find the width, right? You want to find this width right here. So that would be the difference of right, whatever is x of the right, minus the x of left. So in this case, so when it's top minus bottom, we have y minus y, whatever is the corresponding y, so f of x minus g of x. In this case, you need to isolate x from each one. I don't say it's very difficult, but it's not as easy as the other one. For example, isolating x on this side is radical y. And you just take the positive radical y because we are on the positive side. And then to isolate x of the right, does anyone know how do we isolate the x of the right if we were planning to do it, if we had time? Exactly. You would have complete the square first, and then you isolate x. Then you would have find the x of this one too. And then when you were setting the integral, you would have write dy here and the minimum and maximum of y here. So whatever is 0 to 1 in this case. And then radical y minus whatever you found as of isolating x here. Again, in this case, involves a little bit of extra algebra, be avoided. But I want to tell you that sometimes it's easier when you go right minus left and dy. And sometimes it's easier when we do top minus bottom and dx. Okay, so I wanted you to get an idea of what these are. But anyways, if you did it, if for any reason you had time and isolate this with completing the square and you put it here, your final answer should be 1/3 exactly. Like when we did it with the vertical, or with the horizontal cuts and vertical cuts, yeah. Okay, so let's do another one. Any questions?
So when you isolate for both the y's, would you still set them equal to each other to find the intercepts of them, or you just set the x's equal to each other?
Find the area. Example 3. Find the area between y equal to sine x y equal to cosine x, x equal to 0, x equal to pi over 2. Okay. So I want you to graph. So when I say find the area between all of these, means graph y equal to sine x, but only between 0 to pi over 2, because anything beyond that would not be what you're considering. You're going from 0 to pi over 2. So it makes sense that you graph sine between 0 to pi over 2, cosine between 0 to pi over 2. Okay, graph it and see, and graph the line of x equal to 0, which is y-axis, the line of x equal to pi over 2, which would be somewhere here, and then the graph in between them. So just think about it, how you would do it. So let's say a minute. Okay, sine. So you know that the graph of sine is like that. the graph of cosine starts from the top and then goes on the bottom. So I want you to just have at least a general shape in mind. So you may pick points in the process of graphing. Okay. So let's say, start with sine. If I have x and I have y as sine x, when it's 0, and then I want to go to pi over 2, let me find a point in between them, like pi over 4. When x is 0, sine of x is 0. When x is pi over 4, sine of pi over 4 is root 2 over 2. And then pi over 2, sine of pi over 2 is 1. So now you want to graph it. 0, 0. If I have 1 to be pi over 2, I can use my calculator to give me some estimate of what is root 2 over 2. So root 2 over 2, oops, root 2 over 2, 0.7. So that's about 0.7. So if that's 1, maybe this is 0.5, 0.7, somewhere here. So exactly halfway, which is pi over 4, the output is root 2 over 2. Somewhere there. Okay, so that's my graph of sine. So I can mark it as a y equal to sine x. Do you think you can produce that on the test? So again, I want to mention that math requires a lot of patience. So if you think you should know this by not even plotting some points or trying to remember the shape, maybe it's a lot of expectation from yourself. So you are going from 0 to pi over 2 again. It makes sense to pick some midpoints. Sine, when x is 0, cosine of 0 is 1. Pi over 4, again, root 2 over 2. In this case, we also found that they are the point that they are intersecting. If we were not, we should have put them equal to each other. Like you would say, oh, where sine and cosine are equal to each other. Something like that. Okay, pi over 2, cosine of pi over 2 is 0. So beginning point, pi over 4, same point as sine. And then pi over 2 is 0. So that's the graph of, cosine. So y equal to cosine x. Now it's where you need to decide where the shaded area is. It says bounded between 0 to pi over 2 and between the two functions. So you're looking for this area. Why didn't I shade this area? Because that would have been bounded by y equal to 0. They didn't say bounded by y equal to 0. So x equal to 0 is this one. X equal to pi over 2 is this one. So my graph is between these two and also bounded between sine and cosine. So that's why I'm shading where I'm shading. And I put a good number of homework there, I think 10 questions on WebAssign, so you can keep practicing the graph. Okay. So now, here is the important piece. Just follow along and then answer my question. For the first part, for here, do you see the yellow highlight? For the yellow highlight, tell me what is the top function, what is the bottom function? The top function is exactly cosine, and the bottom function is sine. So now let's go to the other part. So what is the top function here? Yes, sine. And then what is the bottom function? Cosine. So you need to set up two different integrals to set up for your calculation. So the cuts here for both of them, the cuts are dx. So I'm going to have two integrals. The cuts of both are dx. With the first one, I have cosine x minus sine x because the top one is cosine. So I have cosine x minus sine x dx. And then my beginning point is 0. My ending point is pi over 4. Agreed? Do you see it clear? For the second part of the graph, let me just color code it with maybe red this time. So again, it's dx, so that's why I put dx. But then now the difference, the top one is sine x, the bottom one is cosine x. So that's why here you would have sine x minus cosine x. And then the limits this time goes from pi over 4 to pi over 2. You calculate each of these integrals, and then you add them together. Let me write one more step and then give you time to complete it. That's right, Greg. Okay, so integral of cosine is sine. Integral of sine is negative cosine, but with the negative of subtraction is positive. From 0 to pi over 4. Plus integral of sine again is negative cosine. And then integral of cosine is sine, but I have a negative behind that, so it's just, I write it down as minus sine x, going from pi over 4 to pi over 2. Okay, now completed. Okay, so I write part of my calculation down. So root 2 over 2 plus root 2 over 2 for the upper, minus substituting 0. And the first one is 0, but then cosine of 0 is 1. So you said minus the bottom one, minus the lower bound. And then here, putting the top one into x. So it's negative 0 and negative 1 minus the bottom one. So minus makes it plus. That's why I have positive here. So doing the math, combining negatives. So it's negative 2. Combining radical over 2 and radical 2 over 2 4 times. It's 2 root 2. So basically your answer should be positive root 2 over 2 and negative 2.
Can you
Okay.
show me how you did the
Hello.
second part?
Right answers. Thank you everyone for participating. Regardless if your answer is right or wrong, I like you to participate so I know where are the common mistakes. I explain that more. Any questions? Oh, actually, I don't hear, it was there, any voice there, so I don't hear anyone recording. Find the area of the region bounded by y equal to x minus 1, y squared equal to 2x plus 6. Okay, so in process of graphing, you know, one is parabola and the other one is a linear function. So just have that in mind. I will graph it here. So y squared equal to 2x plus 6. So you know the opening of this one because you have positive y squared. So opening is toward right. And then you know that this one is, the first one is a linear function. So let's graph it. So y equal to x minus 1. So you go with minus 1 and then up 1, right 1, and so forth. So that's the graph. So you know the other one is a parabola. In order to find the graph, let's find the intersection of the two graphs. That should help because all you need, you know that it's gonna be opening to the right, but what you need is knowing where they are intersecting the function. So I'm gonna put the two functions equal to each other. So I'm gonna put y equal to x minus 1 and y squared equal to 2x plus 6 somehow equal to each other, that I'm able to find x's and y's where they are intersecting. Maybe the easiest way to solve this, if I isolate x. So from the first one, if I isolate x, I get y plus 1. And from the second one, if I isolate x, I get y squared minus 6 divided by 2. That's the x. So I now put the x's equal to each other. So, and then you find the y's. So from the first one, x is y plus 1. From the second one is y squared minus 6 over 2. So I put them equal to each other again to find the intersection. That cancels. So 2y plus 2 equals to y squared minus 6. Take everything to one side and put it equal to 0. So y squared minus 2y minus 8 is equal to 0. So factor it, y minus 2, y plus 2 equal to 0. So y is 4 or y is negative 2. So for y equal to negative 2, it's intersecting. So the graph would intersect. And for y equal to positive 4, the graph is also intersecting. So the detail of the graph, how it looks like, it's not it's not important. You just need to know a rough graph. And knowing that it's intersecting here, that the y is negative 2. That was the y. And then the y is positive 4. Hold on. Let's say this is positive 4 up here. So I need to find the corresponding x to both of them. So when y is 4, so that's the y. So when y is 4, if I put y equal to 4 here, x is 5. So let's say 2, 3, 4, 5. So 5x, 4y. That's one of the intersection. And then for the other one, the intersection when y is -2, you isolate x, you add 1 to both sides. So it's -1. So x is -1. So these are the two intersections. So when it says bounded by this region, you're looking for this area. So on the test, I tried to put graphs that are known to you or you have seen on the homework or on the examples of the book, or I give you some idea of the rough graph. No, this is a still 6-1. Someone asked that question. You're finding the area bounded. Yes. Was there another question? Anyone? Nico, do you have a question?
Oh, sorry, no, did not mean to unmute.
Okay. So now you want to set up the integral. So finding the area, the isolated x, we put the x's equal to each other. You're solving a system of equation, basically. In order to solve that system, you can have any idea that you want. So you may replace the second y by its equivalent up there. You may isolate x's and put them equal to each other. So however you want to do it. Okay, now you want to set up the integral. So the cuts, do you see? I want you to pay attention. If I cut vertically, what would be the problem? Can you see if there is a problem? So for part of the graph, top and bottom are coming from the same function. Do you see that? If I cut it vertically, do you see here is fine, but here they're both coming from the same graph. So in this case, you have to cut it horizontally. So then anywhere you go, right and left are two different functions. So then you would cut one arbitrary rectangle. It's dy, and it would be right minus left. So the right function is y equal to x minus 1. The left function is y squared equals to 2x plus 6. Here's what you need to pay attention. So that's why I brought up this example before moving to 6-2. You want to cut dy's. Things that you are writing here must be in terms of x or must be in terms of y. You tell me. Because you are cutting horizontally, so things are dy. So everything has to be in terms of x or in terms of y. Excellent. So now you want to say right minus left, right? Right minus left. Tell me if I isolate, so things needs to be in terms of y. So means I need to isolate x. So things are in terms of y. So I add 1 to both sides. So x is y plus 1. So my function on the right is y plus 1. Minus left. Now I need to isolate x on the left to be in terms of y. So that would be y squared minus 6 divided by 2. So then I have y squared minus 6 divided by 2. And then another thing. So it's dy. Then what should be my limits? X's or Y's? So my limits should be from -2 all the way to +4 in terms of y, because it's dy. So basically your cut will tell you how to set up the whole integral. So, okay. I'm gonna let you calculate this later, so your final answer must be 18. Okay, so let's move on to 6.2. Any questions here? Let's move on to 6.2. 6.2 is talking about volume of revolution. It's a very, very easy, I would say, topic if you understand what you're doing, exactly like the area. If you know what you're doing, what you're cutting, graphing. When you are doing homework, feel free to also confirm your graphs using Desmos. So Desmos is a free app. For example, for the last one that we were graphing, you had y equal to x minus 1. And then the other one was y squared, y to power 2 equals to 2x plus 1. So DC can confirm the graph, and then you can confirm the points that you're finding. In that case, the points of, so let me see, y equal to, and then you find the points of intersections, and in that case, -2 should be, oh, hold on. Okay, there you go. That's why you see, oh, the intersections are the points that we found already. And then you can go on. I want you to do it manually. Yeah, you get a small note card on the test. But you do it manually.
How do you know that you should cut horizontally and not vertically?
So that's what you decide. For some questions, you may do it either or. But then in this case, I knew I cannot cut vertically, because do you see if I cut it vertically here, what happens? The top function is the pink one. The bottom function is also a pink one. So how do I subtract a function from itself? Do you see that?
Yeah, okay, thank
That's
you.
why right to left makes sense. But there are times that doesn't really matter.
Okay.
Okay. So let's just go to the volume of revolution now. 6.2, finding volumes. And specifically volumes of revolutions. Okay. So let's say you have a graph. This is the graph. Let's say this is the graph of f of x. Y is equal to f of x. That's my graph. I want to find the area of revolution. So it means I want to revolve this graph. Let's say there is beginning and ending. So this is the beginning, this is the ending, this is the graph. I want to revolve it, let's say around x-axis. So this is going to be the shape. Do you see that? You may be asked to revolve a graph around y-axis. Then you would just say, oh, it's going to be something like this. So depending, do you see the red one versus the pink one? The red one is the same graph revolving around y-axis. And then pink one is revolving about x-axis. Are you all with me? So that's the general shape. When the function is given, when one original function is given, and you're revolving. I'm going to write the formula revolving x-axis, but it's going to be the same for y-axis, and we're going to do examples. Okay, finding the area of a small piece and using integrals to add everything, we can find the volume of the function revolving by, so here we go. You're going to take a small piece, exactly like what you did with area. So take a small piece. And I always want you to do this step. It's going to help you to come up with the right answer. So you're going to take that small piece. You're going to revolve this small piece around whatever axis they said. In this case, they said x-axis. When I'm revolving, do you agree that I will have a very, very tiny cylinder? So that's going to be the thickness of the cylinder. As it's rotating, it's going to be a very, very small height cylinder. The height of the cylinder in this case, since I'm revolving around the x-axis, it's going to be dx. Do you see that? Then I need to decide what is the volume of the cylinder. So I'm going to find the volume of this is small cylinder. If I find the volume of this small cylinder, then I'm going to add them all up to get the volume of the whole shape. So I'm going to start with the volume of the cylinder, exactly when I started with the area of that small rectangle. So tell me, in order to find the volume of cylinder, what do I need to know? What is the volume of a cylinder? If I had a cylinder and this was R and this was height, what would have been the volume of this cylinder if this is R? Does anyone know? You're talking about cylinder. Do you remember always volumes, area of the base times height? Exactly. So area of the base, pi r squared times height. That's a general formula for volume of a cylinder. Agreed? Okay, now let's expand the idea here. What is this radius? So in this case, in the question that I created here, do you agree this height, which is the radius right there, do you agree that's equivalent of y, that is f of x? So for example, if this is 4, then the radius is 4. If this is 5, the radius is 5. So it's corresponding to the y value, which is the same thing as f of x. So then the radius here is f of x. So in order to find the volume of this small cylinder, I have pi r squared, f of x squared, times height, which in this case is dx. Agreed? I need a couple of confirmation to see if you understood how did I find the area, the volume of this small cylinder. So I brought a small cylinder out. Great. So now I'm setting my integral. I'm adding all these tiny volumes together. Let's say the beginning point is A, the ending point is B. So it's going from A to B. I need to put dx in there quickly because that tells me that my limits are x. Things inside needs to be in terms of x. So it's pi f of x squared and then dx. That's the volume of this shape. F of x could have been anything, could have been a linear function, could have been an exponential function, could be anything. Does that make sense? Okay, let's do an example now. To have that general idea, rather than just memorizing the formula, I would say have the general idea in mind. Yeah, you could pull pi outside when you are calculating because it's constant. I just put it there because I wanted you to show that that's working together. That's in process of solving. Yes, you can pull it out. Yeah, that was a question of two people. Yeah, definitely. In process of calculation. Yeah, you can. Okay. Any other questions? So let's do this one. The volume of a sphere so this is again to confirm that our I'm going to write example 1 again because this is another section. So confirm of our formula works. Find the volume of a sphere, radius r is v equal to 4/3 pi r to power 3. Okay. So let's do this one. Do you agree in order to find the volume of a sphere, I can have a half circle and I can rotate that along x-axis. So I can have a circle of radius r, half circle, semicircle of radius r, and then I rotate it along x-axis. Do you agree that the output would be a sphere? Yes? So I'm going to take a piece. You need to do this step because regardless how the shape is, if the revolution is about x, about y, or another line, so this would help you to find the volume correctly. So you would just graph, so you say, I'm revolving this. So you're going to graph this one outside. The thickness of, or the height of the cylinder, it comes from dx. So I'm going to put dx here. Now I want to put the radius in order to find the radius there. That comes from the y value that is corresponding to my half circle or semicircle. So yesterday we did this, hopefully you remember that x squared plus y squared is equal to r squared, that's a circle. If I was isolating y from here, I would take x to the other side, so r squared minus x squared, and then taking the square root of both sides, positive and negative, but I only consider the positive because I'm talking about upper part. Okay, so now the radius is corresponding to the radius of my shape, my cylinder is corresponding to radical r squared minus x squared. Or my f of x is that, or my y is that. Okay, now finding the volume of the small piece is pi radius is square. Radius is square in this case is r square minus x square times dx. So that's going to be the volume of this tiny piece, pi r square dx. And then it's going from negative r all the way to positive r. So now let's calculate. So luckily, these cancels. So my integral is from negative r to r. I'm going to pull pi out. R square minus x square dx. R square with respect to dx is a constant. So the integral of that is just r square x. It's like 5, 10. So what is integral of 5? 5x. Integral of 10, 10x. R square x. Because that, with respect to dx, that's like a constant, acting like a constant. Minus x cubed over 3, going from negative r to r. Just keep in mind, I'm replacing x's with r and lower with negative r. Okay. So that's pi, replacing r in here. So it's pi r cubed minus r cubed over 3. Minus, now replacing the lower, that is negative r. So r squared times negative r is negative r cubed. And then negative r cubed on the second one, it's negative r cubed. And then with this, it's going to be positive r cubed over 3. So now you're distributing the negative. And you're combining them. So this is going to be positive r cubed, and that is going to be negative r cubed over 3. So r cubed and r cubed is 2r cubed minus 2r cubed over 3. So that's pi r cubed plus r cubed is 2r cubed minus 2r cubed over 3. Getting a common denominator. 6 minus 2 is 4r cubed over 3 times pi. Which is confirming 4/3 pi r cubed volume of the sphere. Okay. That was one example of area of revolution. So I'm going to give you a minute or two, look over the setup and let me know if you have questions. So example 2, find the volume of revolving y equal to radical x minus 1 around, let's say our graph is bounded between radical y equal to radical x minus 1, y equal to 0, and x equal to 5. Whenever you found what this shape is, I want you to revolve it around the x-axis. So always start with a rough graph. If we talk about parabolas, make sure you're comfortable with the graph of parabola. If we talk about radicals, make sure you know. So you just know the general graph of radical x, and then in this case, moving it 1 to the right with translation of 1 to the right. Okay, so I want you to graph this one, and then just come up with an idea what would be that revolving x-axis. So I'm going to give you a minute to just come up, do a rough graph here. So radical x is a function like this. You're moving 1 to the right, so it's going to be a function like this. So I'm going to just graph the move. So it's starting from 1 and it's going up. So that's my graph. It's bounded between y equal to 0, which is x-axis. So this is y equal to radical x minus 1. X-axis is the same thing as y equal to 0. And then y equal to 5, let's say somewhere here. Sorry, x equal to 5. So line of x equal to 5 is a vertical line passing through 5. So when x is 5, just keep in mind the corresponding y is also 4. When you replace 5 here, it's intersecting the graph at, radical 4, which is 2. You replace 5 minus 1, 4, radical 4, 2. Yeah. Okay. So now you are taking a piece out of here and you are revolving that around the x-axis. You are revolving that around the x-axis. So here's what the shape would look like. So I need to come up with the radius. So it's the cut is dx. Radius is corresponding to the y. The y is radical x minus 1. Or you could just write y equal to radical x minus 1. But you know that since it's dx, your integral of things needs to be in terms of x. If that makes sense. Okay. So I'm going to set up my integral. I have dx pi, outside, inside, doesn't matter, pi r square. What is r? Radical x minus 1 square. And since it's dx, I need to go minimum and maximum value of x, 1 to 5. Square root and square cancels. So that's radical, that's integral 1 to 5 of x minus 1 dx times pi. So x squared over 2 minus x times pi 1 to 5. So you're just evaluating. What would be the evaluation here? So that's 25 over 2 minus 5 minus 1/2 plus 1 all times pi. 12, 7, 8. So I think 8 pi is the answer. Okay. Any questions? So do you see the setup? So I want you to look at this one and see if that makes sense. Okay. Let's do another example. This is coming from the textbook, example 3. It's coming from page, I think, 446. Question number 5. X is equal to 2 radical y. X equal to 0, y equal to 9. You want to find the volume revolving this around y-axis. So I want you to come up with a graph here. You can plot points. You know the behavior of radical, but this time is radical y. So probably you know that it's exactly inverse of what you did with x, or you can just plot points and figure out a rough graph of how this looks like. So when x is 0, for example, y is 0, that's 1 point. You know that it's bounded between y equal to 9. So let's say, you know, at some point, that's where the cutoff is, and then x equal to 0. So these two are the cutoffs. So cut up here, and cut up here. You just need to graph this at this point. I give you a minute, think about it, and then we'll do it. Okay, let's graph that. So when x is 0, y is 0. So this is 9, this was 0. When y is 9, x is 6. So basically, 6, 9 is the point of intersection of the two. So this is the graph that you are revolving around y-axis. So you are taking a chunk and you are revolving that around y-axis. So the graph that you're pulling outside is horizontally this time. The cuts are dy, and the radius is corresponding to the x. And remember that if it's dy, I need to have things in terms of x. So that's something else that you may remember. So things needs to be in terms of x when you have dy. So your graph is in terms of x, means I need to have things in terms of x at the end. The inside has to be in terms of y for my integral, so it has to be x equal to 2 radical y. So now setting up the integral, I have dy, so I know that pi r square, my r square here has to have things in terms of y because that's dy. That's 2 radical y. So pi r square, that's the radius square. And then going from minimum and maximum of y, 0 to 9. So that's pi times 4. I can pull that 2 squares 4 and I can pull it out. And then 0 to 9. Radical y squared cancels to y, dy. So that's 4 pi y squared over 2 going from 0 to 9. And the answer to that one should be 81 times 4 pi over 2 which that cancels 162 pi is the answer. Okay, any questions so far? Yes, no? So we're going to talk about 6.3 tomorrow. I want to tell you what are your classwork assignment for today. Means you need to practice these. And again, after each class, we have 1.5 hours that you need to work independent on things. So let me bring this up. On your Canvas, let's say when you click on your Canvas, when you go to the Canvas of your course, click on modules for today. Click on 6.1 through 6.4 notes. Please pay close attention. This is how you're going to prepare well for the homework and for the test. So if we were in class, we had another 1 hour and 15 minutes together. So this is hybrid. So it means for that 1 hour and 15 minutes, I want you to do what I'm telling you right now. Starting 6.1, we did some of these examples together. So, and then some not. So I want you to do number 4 of the note, anything that we didn't do together as 6.1. So I want you to do it yourself, cover the answer and see if you can do it. So when you scroll on 6.1, we did example 1, 2, 3. The 4 here, we didn't do it. So you do it as a classwork. 5, we did it together. 6, we didn't do it. So I want you to do problem 4 and 6 out of the note. Do not look at the answer, cover the answer and see if you can produce the answer. Make sense? That should be included in your note that you're sending to me tonight. In 6.2, we did example 1, we did example 2 and 3. I want you to do example 4 on your own and send me your answers. So 3 problems that you need to send me along with today's note. Does that make sense? So we are done with 6.1 and 6.2. If you need, so tomorrow when you come to class, we're gonna be doing some of these activities of 6.2 before starting 6.3. So, but before that, I want you to finish everything that is in notes of 6.1 and 6.2 as far as the problems that I did. Is that clear what you need to do? So you can find the notes. It's just one. So if you want to take a screenshot of them, feel free. So problem 4. So basically you scroll in notes of 6.1 and 6.2, anything we didn't do. So we didn't do problem number 4. So do that of 6.1. And problem number 6. Of 6.1. In 6.2, we did all of them except the last one. So I want you to do that. And it's revolving around y equal to 1. See how that plays. Tomorrow, when you come to class, we start with the worksheet. So 3 problems to be added to all the notes and problems we did together today. Clear? And then turn it in under today's assignment, 6.13. click on syllabus, there should be a PDF. So anything we did in class, plus these 3 problems, 6.1, number 4 and 6, 6.2. Yes, Summer has the summary of that for us. Let me just share it with everyone. Thank you, Summer. Okay. Of the note. Okay, so